Hello to everyone. In this video, let us discuss Werner theory and its applications. So now, according to Werner theory, that what is the need of Werner theory here means to explain the structure of coordination compounds. Werner proposed this theory. So according to Werner, central metal atom, or we can say central metal ion, present in complex compounds exhibit two different types of valencies. So the first one is primary valency and the second one is secondary valency. Primary valency is equal to its oxidation number, and it is indicated with dotted lines, and it is satisfied with negative ligands only. Negative ligands only. Okay. And it is non-directional in nature or non-directional valency. And it is also said to be ionizable valency. That means what here? The ligands which are bonded with primary valency, they can ionize from the compound, from the complex compound. Now come to the secondary valency. This secondary valency equal to coordination number. So it is a fixed quantity and it is indicated with thick lines and it is satisfied with neutral or negative or even with positive ligands, and it is directional valency, having directional nature, and it is said to be non-ionizable valency. It is said to be which one? Non-ionizable valency. That means the ligands which are bonded with secondary valency, that means with a thick line, they do not ionize from the complex compound. Okay, now let us see the complex compounds of cobalt, how to draw their structures using these two valencies. Okay, first one is COCl3 6NH3. That is the first complex compound. Let us see how to draw its structure using primary and secondary valencies. So the first compound is here COCl3 6NH3. Its primary valency is equal to oxidation number. Now here cobalt oxidation number we have to calculate. Ammonia is neutral ligand. So now here x minus 3 plus 0 equal to 0. So we can write like this here. X plus 3 into minus 1 plus 0 equal to 0. Therefore, we get x equal to plus 3. So that means oxidation number of cobalt is plus 3. So primary valency is how much? Means 3. And secondary valency of cobalt is, that is 6. It is a fixed quantity. Now here, first let us consider CO. We have to draw the 3 dotted lines because primary valency 3 and it is satisfied with negative ligands. So we are writing Cl minus ligands here. Now its secondary valency 6. So let us draw the 6 thick lines. Now these are satisfied with neutral ligands. If they are not available, negative ligands will take that role also. But no need to worry now. 6 ammonia molecules are there. So they can satisfy the secondary valency. As 3 chloride ions bonded with primary valency, those only ionize from this complex, not the remaining ammonia molecules. So now, whenever it is treated with excess of silver nitrate, COCl3 6NH3, when treated with excess of silver nitrate, what we can get here? 3AgCl precipitates, because 3Cl minus ions bonded with primary valency only. Okay, now this is having which one means a white color. Okay, then what is its original formula means CONH3 taken 6Cl3. Already we know that this sphere is called coordination sphere. This is ionization sphere. As 3 chloride ions present in ionization sphere, this will give which one means 3AgCl precipitates. Okay. In another language, if you want to understand, we can go for another language. Consider cobalt as a king. He always need 6 bodyguards. So these 6 bodyguards always inside the fort, not outside the fort. So that king need 6 bodyguards. These 3 are which one? Let us consider like gatekeepers. Now, as these are present outside the fort, they can move freely anywhere. But these 6 members could not move freely. That means these 3 chloride ions only now ionizable, but these ammonia molecules are not ionizable. For suppose if any one gatekeeper enter in place of this bodyguard, that gatekeeper also unable to move anywhere. So we have to feel like that. Now come to the second example here, COCl3.5NH3. So now here, this is also having primary valency 3 and secondary valency 6. In that no doubt, because here X plus 3 into again minus 1 and ammonia 0. Again we can get X equal to plus 3. But one ammonia molecule is not there, because 5 NH3 molecules only there. Now what happens here? One of the chloride ions satisfies both primary and secondary valencies. That means here from this complex compound, only these 2 Cl minus ions will ionize, but this chloride doesn't ionize because it is satisfying both primary and secondary valencies. Now, whenever this is treated with excess of silver nitrate, we get only 2AgCl precipitates. We can't get this chloride ion as a precipitate. Now, what is its formula means? Now, here one ammonia molecule is not there. Only 5 ammonia molecules are there. That means this king need 6 bodyguards. So what happened now? We called one of the chloride into this which one coordination sphere. Now one chlorine and get into that which one coordination sphere. 2 chloride ions only present in ionization sphere. So these chloride ions only now precipitate as which one? AgCl. Okay, now let us see another molecule, another complex compound, COCl3.4NH3. Here also primary valency 3, secondary valency 6. But here again another ammonia is escaped from the compound. Now what happens here again? This time another chloride ion also take the role of both primary and secondary valencies. That means in total, only one chloride ion is having primary valency. So whenever it is treated with excess of silver nitrate, we get only one AgCl precipitate. This chloride comes out as a precipitate. Now, what is its formula means again same. As one ammonia molecule is decreased again, now we have to call up another chlorine into the coordination sphere. So that means cobalt should satisfied with 6 secondary valency. That means coordination number. So we have to keep total 6 ligands around cobalt. This chloride present in ionization sphere, that only can ionize as AgCl. Now let us see COCl3.3NH3. Here again another ammonia molecule is displaced or disappeared. So that means here again we have to remove another ammonia. Now this time this chloride also participate in that secondary valency. That means all the three chloride ions now satisfying both primary and secondary valencies. Now, when this treated with excess of AgNO3, we get 0 AgCl precipitates. That means no AgCl precipitate is formed. Now, its original structure can be written like this here. CONH3 taken thrice Cl3. So like that, no ions are produced. So totally, which one give how many ions? Let us see here. First, I will write that formula. Then we have to see how many chlorides are satisfying primary valency and how many chloride ions are satisfying both primary and secondary valencies also. Let us see here. So first, COCl3 6NH3, and its structure we have to write like this: CONH3 taken 6Cl3. So it is 1:3 type of electrolyte. It will give total 4 ions, 3 Cl minus ions and 1 CONH3 taken 6 plus 3 ion. Okay, then COCl3.5NH3. Its structure we can draw like this here: CONH3 taken 5Cl, Cl2. It is 1:2 type of electrolyte. We get 2 Cl minus ions and this total complex coordination sphere as 1 ion. So total number of ions produced how many? 3 ions. COCl3.4NH3. Its formula can be written as CONH3 taken 4 Cl2Cl. It is 1:1 type of electrolyte. Total 2 ions one can get. COCl3.3NH3. Its structure can be written as CONH3 taken thrice Cl3. 0 ions are produced. So it acts as a non-electrical conductor. It is not a electrical conductor because no ions are produced here. Ions are not produced. So like that we can get which one here? Number of ions 4, 3, 2 and here 0 number of ions. That means electrical conductivity decreases from COCl3.6NH3 to COCl3.3NH3. Now, what are the questions we get regarding this Werner's theory? Let us see the type of questions here. So now the first question I give here. So see the first question here. COCl3XNH3 when treated with excess of AgNO3 that produced 2 AgCl precipitates. What is this X value? That is our question here. What is that X value? So now here, as this treated with excess of AgNO3, we got to 2 AgCl precipitates. Now this indicating what? Out of the 3 chloride ions, now 2 chloride ions present in ionization sphere. So the chloride ions which are present outside the coordination sphere, that is in ionization sphere, those only come out as precipitates. As 2 AgCl precipitates are formed, this indicating that 2 chloride ions present in ionization sphere. That means one of the 3 chloride ions enter into which one? Coordination sphere. Now when one chloride ion is entered into that coordination sphere, that indicates what here? Only 5 ammonia molecules are there, because the secondary valency of cobalt is how much here? 6. That means one chloride ion entered into coordination sphere means already how many are there? Means 5. So now the X value is how much? Means 5. Okay, now if the same question we got like this, what is that question? If COCl3XNH3 when treated with excess of AgNO3, 1 AgCl precipitate is produced, then what is the X value? So now how we have to think here? 1 AgCl precipitate produced means 1 chloride ion present in ionization sphere. That means outside the coordination sphere. That means 2 chloride ions enter into that coordination sphere. So actually cobalt coordination number should be secondary. That means coordination number secondary valency should be 6. Now 2 chloride ions entered into that means how many ammonia molecules we have to expect inside the coordination sphere? Means 4. So now X value is how much? Means 4. And one question they give like this also. What is that here? 1 mole of COCl3.XNH3 when treated with excess of AgNO3 produced 14.35 gram of AgCl precipitate. What is the value of X? Like that also they may give the question. So now here consider, okay, 0.1 mole. 0.1 mole of COCl3 XNH3 when treated with excess of AgNO3, we got 14.35 gram of AgCl. So first let us calculate number of moles of AgCl. To calculate its number of moles, we should know molecular weight of AgCl. So molecular weight of AgCl is 108 silver, 35.5 is which one? Means that chlorine. So what we can get here? Okay, 143.5. So this is the molecular weight of which one? AgCl. We got 14.35 gram of AgCl. That means number of moles of AgCl equals to 14.35 by 143.5. Means we get 0.1 mole. So now let us come to the question. 0.1 mole of this complex compound on treatment with excess of AgNO3. What we got here? 0.1 mole of AgCl. That means in another language, instead of 0.1 mole, we may take 1 mole. 1 mole of this complex compound on treatment with excess of AgNO3 produced 1 mole of AgCl. Just multiply with the factor of 10. 1 mole giving 1 mole of AgCl. That indicates what? 1 chloride ion present in ionization sphere out of the 3 chloride ions. That means 2 chloride ions entered the coordination sphere. When 2 chloride ions will enter into the coordination sphere? When number of ammonia molecules are 4, then only two chloride ions enter into the coordination sphere. Now, what is that X value means nothing but to 4. And another question we can get here, what is that PtCl4 dot 2 NH3, or we can take PtCl2 dot 4 NH3 when treated with excess of silver nitrate produced 2 AgCl precipitates. What is the coordination number of platinum? Also they may give the question. So whenever it is treated with excess of AgNO3, we got 2 AgCl precipitates. What is the coordination number or secondary valency of platinum? As we got 2 AgCl precipitates, that indicates what? 2 chloride ions present outside the coordination sphere, that means in ionization sphere. That means these 4 ammonia molecules are there in inside the coordination sphere. So this is structure we can write like this: platinum NH3 taken for Cl2. Now this is indicating which one? Coordination number. So therefore the platinum coordination number in this compound is how much? Means 4. So like that we have to give the answers regarding Werner's theory. Okay, in our next video let us discuss which one that valence bond theory. Okay, bye.